Have you ever walked outside in the evening and boom, the street lights turn on automatically? It feels like someone is watching you, but don't worry, it's not ghost. It's just a small sensor doing smart work. Today, we are going to build our own automatic street light system using Tinkercad. And we are not just drawing components, we will understand the real engineering behind it. In this video, I will show you how to use the photoresistor, also called an LDR, to detect darkness and turn on an LED automatically, just like real street lights. And the best part, no electricity bill, no load shedding issues, only pure simulations. Let's understand the hero of our project, photoresistor. In Tinkercad, you won't find a component named LDR, it's photoresistor, same thing, different name. Here how it behaves. In bright light, its resistance is low. In darkness, its resistance becomes high. Simple concept, powerful application. But Arduino doesn't understand resistance, it only understands voltage. So we use classic electronic trick, the voltage divider. When light changes, voltage changes. And Arduino reads the voltage using 10-bit ADC, a number between 0 to 1023. Basically, the photoresistor is telling Arduino, bro, it's getting dark, switch on something. Let's jump into our project. I have used this Arduino Uno LED 220 ohm resistor. This is 10k ohm resistor and this is the photoresistor. We will now build the voltage divider for the photoresistors. Now you can see one side of photoresistor is connected to 5 volt. This side is connected to 5 volt of the Arduino. Other side is connected to the A0 of analog pin of the Arduino. Okay, and same A0 node, this node I have used to this 10k resistor. Okay, and the another pin of this 10k resistor is grounded to Arduino. This gives us the analog voltage that changes with light. Okay, now we have done photoresistor and voltage divider wiring. Now see the LED wiring. I have connected one leg of LED, that is anode, to the 220 ohm resistor and another leg, that is cathode, to the ground. The another leg of the resistor is connected to the 9 number digital pin of the Arduino. This LED is our street light. Now we'll check the code for this project. Okay, here we have declared sensor pin as A0, LED pin as 9 and threshold set to 900. This value is a random value which I have declared. I will show you later how to decide this value. Okay, then in setup I have set up the LED pin, which is the 9 number pin, as a output. We are using this pin as output and we have begin our serial monitor here. Okay, in a loop I have taken sensor value from sensor pin, which is the A0 pin, which is of the photoresistor pin. Okay, and we also printing that value to monitor. Okay, in serial monitor. Okay, I have also used if condition. In if condition, what I have done, sensor value is less than threshold. If our sensor value, which is taken here from the analog read of sensor pin, which is the A0 pin, that value if less than 900, which is the threshold, then digital write LED pin as a high. Then we will send 5 volt to this pin, which is the LED pin. Okay, and if this value, sensor value, is less than 900, which is threshold value, then we are lowering the voltage, that then we are sending 0 voltage to this pin. That means we are getting switch off this LED. Then we have delays, apply some delay. Okay, now it's time to run our code. Okay, to check it's working fine or not. Let's test it. Click on start simulation. Okay, we'll start our serial monitor. Now you will see sun icon near the photoresistor. Now when it's bright, sensor value is high, LED off. When it's dark, sensor value is high, LED on. Now we'll stop at the when LED is getting off. You can check this value is 913. Okay, so we have set threshold as 900. If this value is becomes greater than 900, then LED is getting off. Okay, now if this getting lower than 900, you can see 865, then also LED is on, and if getting more than 900, getting LED off. Okay, congratulations, you just build a street light system. Now you can become a MSCB engineer in simulation only. This exact circuit concept is used in real life. Street lights in every city, solar guards, mobile screen auto brightness, smart home night lamps, industrial machine control panels, and many more. Now, whenever you see a street light turning on by itself, you will say, "Array, this is my Tinkercad project working in real life." If you enjoy this project, hit like, share with your friends, and subscribe because next video is even more fun. And don't forget to comment. Your feedback helps me design better projects for engineering students. Thanks for watching and see you in the next smart project.